Use Ajax, the foaming cleanser.
Alka-Seltzer, plop, plop, fizz, fizz. Oh, what a relief it is.
Double your pleasure, double your fun with double mint gum.
J-E-L-L. Oh, the big red letters stand for the Jello family.
Welcome to Common Point, a program for and about communication. I'm your host, Dan Thomas, and I have two very special guests today from the American Radio Relay League, the ARRL. I'd like to introduce, first of all, Ed Hare, who is the manager of the lab at the ARRL.
Yeah, they call me the lab dad.
The lab guy. And next to him is Mike Gruber, an author of a book and also an expert on RFI, and that's our topic today, radio interference. And I'd first like to get a little background. Ed, can you tell us a little about what the ARRL does and what you do there?
Yeah, well, ARRL is the National Association for Amateur Radio. This is a private radio service available to anyone who can pass a simple exam, lets us operate on a wide range of frequencies, and well, literally talk all around the world, sometimes with a simple wire in the tree. There's over 700,000 licensed amateurs in the United States. We're their national association. We have about 170,000 of them now as members.
Now, what do you do specifically? What's the lab for?
Well, the laboratory is the technical resource. We do all the high-tech stuff in support of the organization. It ranges from answering questions from our members who will call up and how do I use this particular type of radio? How do I put up an antenna? We get some questions like that. We get questions about radio noise and interference, which is what we're here to talk about today. We're also doing a lot of the research and development that we will do in preparation for a lot of our work with the Federal Communications Commission on radio noise, on other regulatory matters. And my own job takes me a lot into industry. I work with an engineering group called the IEEE,
Yes.
and I'm on their Electromagnetic Compatibility Society. I served on their board of directors until the end of last year, and now I'm their vice president of standards. So we're pretty well connected to a lot of the industry groups that are happening as well.
Very, very definitely. Excuse me. Mike, what is your role at the ARRL?
Well, I'm primarily involved in solving interference problems, mostly for amateur radio operators, but we also do, we try to help in cases where a local radio station may have an interference problem, or a listener of a broadcast station sometimes will contact us, and I always try to help when I can. So we do quite a bit. It keeps us pretty busy. And as Ed mentioned, we're involved in IEEE quite a bit, and I'm the chairman of a working group that is helping to develop a standard for the resolution of power line interference problems.
Now, Ed, I'm going to ask you first. In fact, excuse me, I'll ask you both. But how big a problem is this interference?
It's quite the problem. Years back we had simple electronics devices. We had simple incandescent light bulbs. Our power supplies used in all of our electronic equipment were quiet. Now they're making LED bulbs. They're making a lot more fluorescent bulbs. Every single power supply and every device we have is now a potential source of radio noise. We have electronic computers in most of our devices. They're sources of radio noise. So we're seeing more and more noise problems that we didn't have, say, 10, 15, or 20 years ago. It impacts the ability of not only amateur radio operators to do what they do with radio, impacts broadcast spectrum. The AM broadcast band is now in many, many areas. You go to an apartment building or you go into a small commercial building and turn on an AM radio, you might not hear any AM stations at all, even when you have some fairly close. FM doesn't sound as noisy, or TV doesn't sound as noisy because of the digital aspect of TV or the nature of frequency modulation or FM, but it's going to impact the ability to hear signals that maybe you used to be able to hear. We talk to broadcasters all the time who will tell us, well, we're getting complaints from our listeners who will say, I used to hear your station really well, and now all of a sudden you don't sound so good. It's noisy.
Mike, how does this impact, I guess, the average citizen overall? We've got an audience out here that most of them probably aren't particularly oriented on this. How does this impact us?
Well, interference from various sources, such as power line noise, can impact telephone, home phones, TV and radio reception. We had an interesting case a few months ago in which a police department in Evanston, Illinois contacted me and said that they were having problems in a certain neighborhood of Evanston in which people were unable to start their cars with key fobs. And other devices such as cell phones didn't work. They, in some cases, couldn't start their automobiles. And they contacted us for looking for help, essentially. And one of our directors now, and also chairman of our EMC committee at the ARRL, lives not too far away from there, checked it out and found that a neon sign transformer for a store, was generating the noise, and it was so strong that it was affecting these other RF devices.
Yeah,
So,
I mean, that remote starter for your car, or even something that'll unlock the doors, is a radio device. So it's susceptible to radio noise from a strong local noise source.
And in that case, it would have represented, or could have represented, a real threat to the public safety if someone had to contact an ambulance, for example, or call the police department. They would not have been able to get through, and they couldn't start their cars. What they were doing was towing the cars out of the area to start them.
Wow. Now that's real interference, and from a source you wouldn't expect.
That's an extreme example.
A neon sign in a store. Well, as technical people, we understand that this can create radio noise. Yes. The average, person out there is not going to quite associate the fact that my car won't start and there's a sign in that store.
That's right.
And so, these devices, there are Federal Communications Commission's limits on them. A lot of times those limits are either not met or can result in some interference. And so that the growing number of devices and the growing potential for susceptible devices. I mean, years back when you had a car, it had a key. You turned it, it started. Now you have a radio device that needs to work in order for you to even be able to unlock your car.
Now that affects us all.
Oh, absolutely.
Definitely. Now, Mike, what about international? We have a lot of imports. I don't want to specify any country, but does everything have to meet a standard in this country, or can we get hoodwinked, I guess, into buying things that cause more interference than it should?
Yes, good question. There are emissions limits that have been set by the FCC for electronic devices, and those limits are not high, are not low enough to prevent harmful interference from occurring. But if the device does meet the limit, it's only going to be a small localized problem. The scope of it will be very manageable to address on a case-by-case basis. However, we are seeing cases in which light bulbs come to mind. People are buying them online from overseas sources. We have looked at some of those bulbs in the lab, and they exceed the limits by a considerable margin. So
one of the high-powered lighting controllers that are being used for some forms of indoor gardening was generating a lot of orchids, we don't know, but generating a lot of radio noise. We managed to obtain one of the devices, and we did some testing in our laboratory. And I'll first express it in engineering terms, as this was 58 decibels greater than the FCC limits. Wow. To translate this into layman's terms, that one device was making as much radio noise as 650,000 legal devices. And this was something made in China. It had labeling all over it. We meet all the regulations. They clearly didn't. We reported that to the Federal Communications Commission. But there are devices out there that are coming in, overseas perhaps, sometimes U.S., that exceed these limits by a little bit or a lot. I bought a battery charger recently. We tested it. We bought it from one of the larger stores that sells inexpensive products, right. And it measured about 30 dB over the limits, as much noise as 1,000 legal devices.
when buying anything, particularly let's talk about light bulbs because that's something everybody buys. And they're buying new LEDs. I know when we were talking before the show started about some conversions I've been doing for the museum and for my house. What advice do you have for people in buying these?
Well, there's no real way to know when you buy it whether it is going to be causing radio noise in a way that'll impact you. I mean, if it were to generate noise on a frequency that you never listen to that station, well, it's not really interference to you. And some of the devices, we've done a lot of testing of these. We've gone to like some of the large box stores, bought a few samples of each of the brands they sell. We found the vast majority at least meet the FCC's rules, and that's a good start. What I would suggest, especially to an amateur operator, but even to a consumer, if you're going to replace all of the bulbs in your house, go buy one. Just one. Plug it in and put your radio near it and see if it's going to cause interference to your favorite radio station or stations. If it doesn't, then you can feel pretty comfortable about replacing all the ones in your house.
Very good advice. Mike, how do we detect it? How do we detect this interference? Somebody calls and says, I have a noise problem. What is the next step? What do you do?
Well, how to find it? Or how to address the issue?
Yeah.
Assuming that it is an RFI problem? Mm-hmm. Okay, one of the first things I would recommend, if you can do it, is to simply listen to the noise with a battery-powered radio. Trip the main breaker to your home and see if it goes away. Most of the time, you'll find that it's in your own home. From that point, if it is, you can trip the individual breakers and further isolate it in that manner, and then once you know roughly where it is or the room, you can always unplug suspect devices one at a time until it goes away. If you find that it is outside your house, external to your home, I would recommend that you contact the radio station that you're trying to listen to. Let them know that you're having a problem hearing their station and you would like to. And another thing you can do is contact the FCC and file a complaint. Two ways of doing that. One is an online complaint process that they have, and you can provide the URL for that. And the other thing you can do is call them.
Let's define URL.
The Internet web address.
Internet web access, an online complaint filing process. So here's the link that you can use. And then there is a phone number that you can call and talk to someone. Generally, I think from what people are telling me, the online process works easier. It's easier to manage. And so once you've determined that the source is external to your home, in almost all circumstances, it generally turns out to be either power line noise, which is caused by arcing on power lines, or a consumer device in a nearby home. If the source device meets the FCC limits, it's probably a few hundred feet away from your home. So it's a very close neighbor.
Yeah, it's an immediate neighbor.
It's an immediate neighbor. And oftentimes, if you look at the transformer that your house is connected to on the pole outside your home on the street, look to see which transformer it is and see which other homes are connected to that same transformer. It's oftentimes in one of those houses.
Yeah, you're all sharing the same wiring, where that transformer, you have a wire to this house, a wire to this house, so noise can go from one back down to the other.
What does it sound like, Ed, excuse me, Mike? I understand you brought a sample of noise power line.
One of the most common types of noise that we get, it's power line noise. That's the arcing source that I talked about earlier. And but I mean, really, you can get interference from all kinds of electronic devices, and it may not necessarily sound like this, but this is power line noise. And that's what it sounds like.
And of course, that's just the noise. If you were listening to an AM radio station, that noise would be overlaid on top of what you're trying to hear.
Right.
And a key factor there is that it will always sound the same everywhere you tune on the dial. It doesn't change tone or characteristics. It sounds exactly the same everywhere you tune.
Now, Ed, we were talking about that incident with the bad neon transformer.
Yes.
How do you track something like that down?
Well, Mike has it here. Is there's technical ways to track it down. For example, this is a receiver that is designed specifically to get noise signatures, and so you can say, I'm going to have noise here. You connect it to an antenna at the place where there is interference. You get a signature. You now take this out into the world with a portable antenna and look for noise sources. You then compare the signatures. That's the hard way because most people do not have one of these. The average person who's going to be looking for this may want to either, again, contact the radio station or the TV station for which you're having some trouble. They can often help. Or if you're going to have to track it down, you can at least rely sometimes on some of the clues. For example, if you have noise that is somewhat similar to what Mike played, you tune your AM dial and it sounds the same almost no matter where you tune it, that's more than likely going to be some sort of a power line noise. You can have problems with insulators, loose staples. Every once in a while, that power line noise can be a symptom of a failure in progress. This could be leading to an outage or even worse, dropping a line on the ground. So if you do suspect power line noise, you can also contact your local power company. They'll often come out if it looks like it's their equipment. The FCC rules would say they need to fix it. The other things you can do is if it's noise that comes on at a certain time of day, pay attention to what's going on in both your own home and your neighborhood. If the noise comes on 5 minutes after George comes home next door, then you know it's probably some device in George's house. If it's on for 5 minutes in the morning, maybe George is shaving. We don't know. So, and those are really the kind of things I think consumers can do. If you happen to be lucky and have an amateur radio operator in your neighborhood, that ham might be able to help quite a bit too because he understands a lot of the issues. He has access to people like Mike and I who can advise him on how to be helpful in his neighborhood.
Now, Mike, let's talk about ham operators. We're all hams here. I have heard interference, of course, but hams get blamed a lot of times when it's not their fault. What does the ham do?
Well, one way to handle that is to, hopefully your neighbor will cooperate, is to conduct a test in which your neighbor can have someone present at the station and you can have someone present at the affected device in your neighbor's home and transmit, see if the problem occurs or goes away. And usually that will satisfy everyone. In some cases where the problem is very intermittent, oftentimes the ham will say, I'm not even home, I'm out of town, or I'm at work.
Well, we have a joke in amateur radio is if you put up a new antenna, don't connect any transmitters to it until you take care of all the interference it causes.
I like that suggestion.
Yeah.
And speaking of interference, another piece of interference as a ham I get, and that's I have a 2-meter rig, of course, in fact, 2-meter 440 in my car, and it's on all the time that I drive. Certain cars will hit a certain repeater frequency. I'll be driving down the street and all of a sudden I am to the point now I know the brand of car and probably the year that will cause this. It's not long term, it's a short distance. Is there anything that can be done about that with a car manufacturer?
No, not really. We work a lot, with IEEE and with the Society of Automotive Engineers. So we work with a lot of these car manufacturers. But even one of the ones, and I'm not going to name them by name, but one of the ones that we worked with very intensely designed a car that had that kind of noise problem right on the most common frequency used by amateur radio operators. Oh. And so we gave them a hard time about that. But the place to address that is at the design stage. The manufacturers are generally doing it. There are standards, again, for the automotive industry. But once that car is designed, it's not really going to be possible to easily redesign that car to make noise on some different frequency. The suggestion I would have for anybody buying a car, or even if you're not an amateur operator, is go to the car, tune on the FM radio to your favorite station, and see if the car is making any noise that might interfere with that station.
And if you're a ham, sweep your repeaters.
Well, yeah, exactly.
Bring a portable radio.
Right, because bring a portable radio,
Yeah.
bring a battery-operated radio, and listen to the repeaters you want to use to make sure that it's not going to cause you problems.
And during a test drive.
Right, and during a test drive. Now, when you're driving down the street and you get like 10 seconds of interference because that guy is passing you at 90 miles an hour, that's something that the Federal Communications Commission would not really consider harmful interference. I mean, you're not going to file a formal complaint, get the guy's marker number. It's just noise happens.
Now, Mike, I know you were a part, in fact, you were the editor of a book on radio frequency interference that the ARRL has available. I have a copy. By the way, it's an incredibly comprehensive book and reference source.
Thank you.
How did you how did you get involved with working on that book?
Well, actually, it was Ed that...
This is a funny story, if I may tell it, Mike. We've always had someone doing radio frequency interference work. It used to be me. I get then promoted to lab dad, so it was. We hired a person who was then no longer with us. And Mike used to work for us years ago doing equipment testing. He went on to greener pastures, as it were, but he was between positions when we had a job opening. So I arranged an interview with Mike that he didn't know was a job interview. I took him out to lunch.
We went out for lobster.
We went out for lobster, and I talked to him a lot about this. I knew his capabilities as an engineer, and although he'd had no direct experience, I knew he could do this job. So I went back, talked to our management, called him up later that afternoon, made him a job offer. He probably fell over in his chair. And of course, among the many things he needed to do was to continually update that radio frequency interference book. I did the first editions of it. We then had the gentleman that was between me and Mike do another edition, and Mike picked up on it from there. And he's done a great job. Look what they done to my song, Ma? Well, he did a great job with my song. It's a good book.
I think Ed actually did do the first edition.
I did the first edition.
Yeah.
And so what we've tried to do with this book is it's information about all of the aspects of radio interference, including the most important that are really glossed over in a lot of engineering publications, the social aspects. Because you're an amateur operator and you're the one who has the technical knowledge. Your neighbor is not necessarily technical, and so helping your neighbor understand what these issues are is really an important first step. I mean, you can know all the technical solutions in the world, but if your neighbor won't let you in the house to try them, you're not going to fix the interference problem. And of course, you have to be a diplomat.
Now, I do know that the book is available at the ARRL.
Yes.
Both online and at the store in Newington.
Correct. 225 Main Street in Newington. And, or order it online, and we can just mail it out to you if you don't want to drive across the state.
One more question.
Sure.
And this is to Mike. In fact, it's to both of you. Is it going to get any better?
Ooh.
Tough question.
I would say yes, but surprisingly. One of the things that we've been doing over the years is we have been trying to work with industry, the people that make these products. We're trying to work with regulators, and not trying to take we want to oppose your horribly noisy products. It's like, we want to help you make them better. Mm-hmm. And we've had some major interference problems from some types of devices where that was exactly the approach that worked, is we were going to work with the industry. There was a technology called broadband over power lines, where they wanted to use those overhead lines instead of excellent Ethernet cables. And it made a lot of radio noise, especially on the shortwave spectrum. And we worked with that industry to try to get them to understand why it was important to take care of noise problems. And so as we continue to address this, I don't know if it'll get better, but I think it's not going to get a lot worse. And so we can continue to work with manufacturers. Our work with the IEEE gives us good standing. If I now call one of the major equipment manufacturers, it's not just some ham radio guy, but this is someone who's in a leadership position with major industry organizations, calling them up to talk to them about a problem and to help them find solutions.
So the problems are solvable. What can a ham do, Mike? What's the best thing an amateur operator can do?
If he has an interference problem, I would say if he could work it out with his neighbor without involving the FCC, he would be, diplomacy, I guess, is the key word. And if he needs technical help, he can certainly call us at the ARRL. We have online resources that he can refer to.
There's, of course, the book.
There's the book, and I'm only a phone call away. But key to it all, diplomacy.
All right. Well, I thank you, gentlemen, for being here.
Thank you.
I would ask each of you, any final comments?
No, I think you did like all of those difficult questions were just the right ones to ask. So,
any final comments from you, Mike?
Thanks for having me. It's been a pleasure.
Well, I'm very, very happy to have had you both on the air. As I say, I've chased some RF in my days, too, as a broadcast engineer. Interference back in the old days when it wasn't so bad. It's disheartening to see it.
it is. And,
at the level it is now. But
and we had a little focus here on amateur radio, but as I think we also drove the point home that this is a problem that impacts everyone.
Yes.
And amateur radio, of course, we often are doing some very sensitive work with low-level signals. So in one sense, we are clearly the canary in the coal mine, but we're also a valuable technical resource, both to industry, to the regulators, and that amateur in the neighborhood. It can certainly help. There can be interference in both directions, but amateurs are usually skilled at first making sure their station is operating correctly, and they'll also help identify the filters that might help on the other end should there be a problem. And so between the two, that amateur can certainly address problems with his or her station, but can also help others find local neighborhood problems.
all right.
Good. Thank you.
Again, thank you very much. Ed Hare, Lab Manager, the ARRL. Mike Gruber,
Thank you.
A testing guy, a guy that knows all there is to know about RFI.
In fact, all the hard work I give to him, and I take all the credit. So, thank you.
Thank you very much for joining us. I'd like to invite you to join us for our next session of Common Point. We'll have another surprise for you. We try to keep it interesting. For Common Point, I'm Dan Thomas. Good night.
Pepsi-Cola, it's the pot, 12 full ounces, that's a lot, twice as much to do. Pepsi-Cola is the drink for you. Nickel, 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 nickel. Pepsi-Cola hits the spot, 12 full ounces, that's a lot, twice as much for a nickel too. Pepsi-Cola is the drink for you.
Funding for Simsbury Community Television is provided in part by contributions from viewers like you. Thank you.